The first reaction we're going to examine is an electrophilic addition reaction. We're going to see the reaction between an alkene, here 2-butene, and hydrogen bromide. Very quickly you will see the double bond attack hydrogen. Hydrogen will kick its electron to bromine, and the carbon will bond with hydrogen. The other carbon will form a positive ion, which bromine, a negative ion, will then attack and bond to. We will have an alkyl halide at the end of the reaction. Again, let's look at the reaction and watch a bit more of what's going on. With the reaction, electrophilic addition between the alkene 2-benzene and hydrogen bromide. The double bond of the alkene acts as a nucleophile which grabs hydrogen. Hydrogen kicks its electrons to bromine because hydrogen acts as an electrophile. Electrophiles attract the attention of electrons, they love them, and nucleophiles move towards positive or quasi-positive charges because that is the charge of a nucleus and they love those. We can look at the thermodynamics, which is the energy states of this chemical reaction, if we draw a coordinate diagram. The y-axis of the coordinate diagram is the free energy of the system. The x-axis represents the progress of the reaction. We're going to use a red line to represent the energy of the chemicals as the reaction proceeds. Here we see the energy of the reactants and the energy that they pick up as they move to the transition state, which is the state at which bonds are breaking and forming. There are two transition states in this reaction and two reactant states. At the end of the reaction, we will see the energy of the products. We can also learn a bit about the kinetics of the reaction, which is the study of reaction rate. Though we can't really know for sure, the parts of the reaction that require the most energy generally are the slowest, or take the longest, and the parts that require less energy generally happen more quickly. So the activation energy in this reaction to the first and highest transition state is the energy that will determine whether or not the reaction happens, and it will also be the step that really determines the reaction rate of this reaction. Finally, when the energy of the products is lower than the energy of the reactants, we call the reaction exergonic. It is a reaction that releases free energy to the system. Now at the end we see again that when an alkene undergoes an electrophilic addition reaction with hydrogen bromide, the double bond is replaced with an attachment to bromine and it becomes an alkyl halide.